Hey everybody, welcome back. So the last time we worked on this, we got the swap chain and its images set up. Now we're going to start creating the graphics pipeline. So let's go ahead and get started. First we're going to create a new function called CreateGraphicsPipeline. So we're just going to do that right over here after CreateImageViews. Just void create graphics pipeline. There we go. We're just going to drag that over like we always do. Right up to the top here. We don't want a void there, but just call it. And then down here at the bottom, we're going to go ahead and call that so we can start setting everything up. Just got to find Create Image Views. Doesn't have to be here, I just would rather it be here. I have lost myself in the code. There it is. Okay, so just right after that, drop in Create Graphics Pipeline, give it its proper scope again, and there we go. So we're going to be using mostly just that function this entire video. But before we get into that function, we're actually going to need to set up the shaders. So in this one, we're going to be creating all of the programmable stages of our graphics pipeline. Right now that means our Vertex and our Fragment shader. So first off, we're going to do the Vertex shader. Now to get into how the shaders work a little bit, shaders are usually written in GLSL, which is an OpenGL shading language, or sometimes in HLSL, which is high-level shading language. Both of these are pretty easy to read, you know, just like any other kind of code. Pretty understandable for humans, if you understand programming. Vulkan uses a bytecode format. It's called SPIR-V, or however you want to pronounce it. It's more easily translated by GPU compilers, but it is not easy to read. The good news is that Vulkan SDK that we're using when we started this project has a compiler in it. It's called GLSL-validator.exe, and that converts GLSL to SPIR-V. So we can write our shaders in GLSL without too much hassle. So I'll go through some of the syntax of GLSL as we write the shaders, but if you want more info, I'm going to include a link to GLSL syntax in the description. I'm going to be writing the code for it using Notepad++, which I have right here. It's a really nice free software, so I recommend it, and I'm going to include a link to it in the description as well. It's free, it's awesome, there's really no good reason not to use it. So let's go ahead and get started with the Vertex shader. So the Vertex shader takes in all of the data for each vertex from the frame buffer. So that's the world position of the vertex and then all of its attributes. And then it outputs that in clip coordinates, along with any of the attributes that were passed in to the fragment shader. So just to go into a little bit about how the coordinates translate. Once again, I'm going to borrow some stuff from Alexander here. This is a diagram he has on his website, and it's particularly useful. So these are the world coordinates that you would get. They pass from 0 to whatever the resolution of your screen is. And then the clip coordinates here just give you more of a position within the display. So what you've got here, 0, 0 is the direct center of your screen. And then -1 is the border. Well, -1 is one side of the border, and +1 is the other side. So along the x-axis it goes from -1 to +1, and along the y-axis it goes from -1 to +1. And one thing I should point out, be aware that the y values actually increase as they go down. It's a little bit counterintuitive if you haven't worked with a lot of graphics rendering before, because most like game engines, for instance, like Unity or Unreal, their y coordinate is moving up. So in both cases, the frame buffer coordinates and the clip coordinates, the y increases as you move down. So let's get into actually creating the shader now. So we don't have any actual input yet. We haven't made the frame buffer, so there's no vertex data to pass into this. So we're going to have to get around that temporarily by hard-coding some vertex data into the shader itself. We're definitely not going to want to leave this, but for the moment it'll serve the purposes we need. So what you're going to do is you're going to open up Notepad++, you're going to create a new file. There's a few things you need to include at the top. We're going to put a little hash version 450. This has to be in any GLSL program. You're just telling it which version to target. And then we also need a extension which allows it to function for Vulkan. It's just going to be extension GLARB separate, gotta make sure I spell this right, shader objects, and then enable. Alright, now we're going to create an output variable. So GL position is it's a built-in variable for GLSL. It holds the clip space output of the current vertex. There's actually quite a few of these output variables, so I'm actually going to include a link in the description that gives you a list of all the built-in shader variables. So it's GL per vertex. That's our output variable. Okay. And then it's a vec4. Oh. Vec4. GL. That needs to be capitalized. Position. Alright. And like I said, we're also going to have to hard code some vertex positions. And the ones that I'm creating here, if you were to render them, you would end up with a triangle. So, vec2, there we go. And then positions, and we'll just make an array of 3 vertices. And then vec2, and we're just going to initialize all of these. Here, we'll do it this way so it's a little bit more readable. So all of the vertices that we're making are going to go inside these parentheses here. I'm just going to drop them down so that they're not all in the same line. So we have making a lot of vec2s here. Alright, so this one, and remember these are clip coordinates, so they travel between -1 and 1. So we have 0, 0, and -0.5. Then we have, oh, didn't mean to put that star there, 0.5 and 0.5, and vec2, and this will be -0.5, there we go, and 0.5. Okay, so that's all of our positions that we need. Now, every shader also needs a main function, just like any other program. So we're going to go ahead and create a void main. If I could spell, there we go. Alright, and inside the main function we're going to assign the GL position. So, we'll just say GL position, and this is why I like Notepad++, because it knows what you're doing. And we're passing it in. You'll notice the positions that we got, those are all vec2, so they only hold 2 variables. And we need a vec4, because to get a true position, it needs to have an x, a y, a z, and a w. So since we only gave it an x and y position because we're making a 2D triangle, we're going to tack those on the end. So we're going to pass in a vec4, and we're going to give it positions from GL. This is a GL vertex index. And GL vertex index is another thing that's built in. It gives the index of the current vertex. So when we have a frame buffer, it'd be going through and grabbing them all. Right now, it's just grabbing these positions, and GL vertex index is going to iterate through all of them. Okay, and so that gives us an x and a y position, and then we're just going to tack on a 0 for the z and a 1 for the w value. And that should cover everything there. So later on, the vertices are going to have other data besides the positions. So let's go ahead and hard code some colors for them right now. The colors can be set any degree of red, blue, or green. So let's have each one be a solid color of one of those. So we're going to make a vec3, call it colors. Once again, it's an array of size 3. And we're just going to assign it a vec3. Do the same thing we did before for the positions. Alright, so vec3. 3, oh, not vec2, vec3. Okay, so 1, 0, 0 should be for red. Vec3, 0, 1, 0 should be for green, and vec3, 0, 0, 1. Now we want to pass the color data for each vertex to the fragment shader, so we need to set up a variable that is output from the vertex shader and input to the fragment shader. So we're going to make a variable called fragColor, and the setup for this is a little weird, so I'll explain it. We're going to type out layout location equals 0, and then say out vec3 fragment, or fragColor. There we go. So what this is here, out vec3 fragColor is pretty simple. It's an output variable, it's a vector3, and we just called it fragColor. The layout location equals 0 is a little strange, but it makes sense. Different attributes are being stored at index locations within our program. So we're saying store this data at index location 0. So later on we make our fragment shader. If we also declare a layout location equals 0 for an input variable, it knows to look in the same location, and that way that same data is being passed on, and we can reuse that as long as it isn't conflicting with anything. I'll show you a little bit more about that in a minute. So we need to assign that fragColor. So just down here in the main we say fragColor equals colors, and once again we're going to iterate through it using the GL vertex index built-in variable. So that should cover what we need for the vertex shader. Now we're going to move on to the fragment shader. So we're going to make another new file. I'm just going to copy over the version and extension because we're still going to need these. There we go. And if you remember, I said we were going to use that layout location thing again. So once again, layout location equals 0. So it's looking in the same index as the one that was passed out, the fragColor. And this is going to be an input variable. So we say in, make sure it's the same type, and fragColor. There we go. And we also are going to want to output from our fragment shader. So I'm going to make another output variable, and I'm going to use the same index because once it reaches here, we've already used this information, so we can override it with the output, which in this case is not going to change much, but it, in theory could, and it probably will later on. So the output from the fragment shader is going to be a vec4, and I'm just going to call it outColor. Now once again we need a main function, so void main. There we go. And we're going to say outColor. Let's tab that over. There we go. Equals, and vec4. And we're just going to pass in fragColor and tack on one last variable, because right now fragColor is passing in a red, blue, and green value, but the color that comes out of the fragment shader actually has 4 variables. It's red, blue, green, and alpha. Ooh. And we want our alpha to be, I kind of messed all that up, didn't I? There we go. We want our alpha to be 1, because we don't want any transparency. If you're unfamiliar with what alpha is, it's the transparency. So that's all the code for both of our shaders. But now we need to compile them. Remember, we've written these in GLSL, and Vulkan is expecting SPIR-V. So we're going to create a new folder called Shaders, and we're going to go ahead and do that. Oh, let me just pull up GitHub here. Alright, so if you remember, we have PV Engine, we have Tester Game. We're going to make the folder for our shaders in Tester Game. So we'll just make a new folder, call it Shaders. There we go. I'll come back to that in a minute. And neither one of these have been saved, so we're going to save as. That's my other one. Alright, so Tester Game, Shaders, and for this one we're going to call it shader.vert. There we go. And this one, save as well. This is going to be shader.frag. Perfect. Okay, so we have those two. Now we need a way of compiling those. So I'm going to make a new file here, and we're going to create a batch file. So if you've never, if you're working on this, hopefully you've created a batch file at some point, but if you haven't, a batch file can just run commands. So what we're going to do is we're going to set up a little program that will run command line arguments without us having to type them out every time. So we're going to save this file. We're going to save it in the same location, and we want it to be a bat file. So right there, and we're going to call it compile.bat. Okay, so you're going to need to call the exe that's in the Vulkan SDK. So you need to remember wherever you stored it. Mine is in C drive, Vulkan SDK, version 103.39.1, and then bin32, and let's see if I can find it in here just to show you. Where is it? Oh, there it is. GLSL validator.exe. So that's what you want to call. So just to simplify things, I'm just going to copy this address right here and go over to the compile batch file and drop it in there. So we have C, Vulkan SDK, the version file bin32, and then GLSL validator.exe. Then we're going to say -v, which is telling it to compile to SPIR-V code. And then we need to tell it which file to compile, so shader.vert. And it's going to be looking in whatever directory we stored it. Since compile.bat is in the same folder as the shader.vert and shader.frag, it'll find them immediately. And we're going to make another call of the exact same thing, except we're going to make it shader.frag, which you probably assumed. And then I'm going to go ahead and put pause, which will just say that once it finishes, it's going to open up a command prompt, it's going to run these, and then rather than closing when it's done, it will pause so that way we can see whether or not it was successful, because you would probably want to know that. Alright, so we've got that saved. Should be good to go. Now we can actually run it and see if it works. So let's go ahead and go to that shaders folder. So we have the compile.bat, we have the two shaders, so I'm going to go ahead and run the compile. And let's see. Did that work? Not enough data provided for construction. Okay. Nope, it didn't work. Yeah, I suppose this is the nice thing about running this. So if you look there, you can see that it's saying line 27. There's an issue. It looks like it worked alright for the fragment shader, though. Let's take a look right here. Yeah, so we have a frag.spv, so the fragment shader worked fine. We do have an issue with our vertex shader, so let's go ahead and take a look at that real quick. It's probably something stupid that I missed. Alright, so let's see here. We have line 27, GL position equals vec4. Sorry, what was that error? Not enough data provided for construction. So we have a vec4, and oh, that's okay. So right here, I put parentheses around this, so it thinks that it's only passing two variables or two bits of data because it was a vec2. It's not getting these other two because there's too many parentheses. So if I take that off, now it should be getting all four. Let's save that and run it again and see if we actually get what we need. So back to shaders, compile. There we go. Yep, so there's vert.spv. So we have our shaders now. So great, now we actually need to find a way to load those in our program so we can stop screwing around with all this separate code. It's interesting, but let's get back to our actual engine for now. So we need to create a way of actually loading these shaders. So we're going to make a function called ReadFile. We're going to put it over here in the Vulkan.h. And, it doesn't really need to be a part of the class itself. So just up here at the top, so still in the scope of PV Engine, but not actually in the Planet Vulkan class, we're going to go ahead and declare a static std vector, and it's going to be characters, and read file. And it's capitalized. go. And it just gets passed in a const string reference to a file name. Okay. We're going to need to declare a new input file stream. So before we do anything, I'm going to include fstream, which will allow us to read files. And we're going to just say std if input file stream. There we go. Call it file. And we're just going to pass in the file name that we've passed through the function. Oh, file name. There we go. And then a few arguments to go with that. So we're going to put in, I'll explain these in a second, it's std ios 8, and then std ios binary. Yeah. So just so you know what these arguments do, 8 will read from the end of the file. So rather than starting at the beginning when it's reading in the file, it's going to start at the very end. And then binary will just read the file in binary format. Now you may be asking why we're starting at the end. We're actually going to use that to get the file size. Now, before we go any further, we should also check to make sure that we actually open the file successfully. So we're going to put if file, well, if not, file is open. And then we're going to go ahead and throw another runtime error. And we'll just say failed, I can't spell today, to open file. And you know what, we'll just say failed to open file. That's good enough. Okay, so now that we have that, we need to declare a file size variable, and we're going to set it to, well, here I'll show you actually. Well, so size t file size, that's file size, there we go. It's going to equal size t file.tellg. And so tellg is going to return the position of the current character in the stream. Oh, sorry, I put file.tellg. So yeah, returns the current character in the stream. Because we started at the end, the current character, its position, will give you the file size. Now we need to create a buffer to store the file that is the same size that was returned to us. So we're just going to say std vector character and buffer, and we just pass in that file size that we got right before it. So that makes it the proper size. And now we're going to go ahead and set the reading back to the beginning of the file and read from start to finish. So we say file.seekg and pass in 0, so that'll seek it back to the 0 index, the very beginning of the file. Then we say file.read, and we're going to read it. We're going to read into buffer data, and for the amount of file size. So that'll read everything we need from the file, and then we just call file.close, make sure we clean up properly, and return buffer. So now we have a nice little helper function. It can take in a file name, read everything from the file in binary format, and then return that buffer in a vector of characters. So let's get right into using that. We're going to go over to our CPP file, go to the create graphics pipeline, and we're going to just read in both of those. So we're going to make an auto variable, call it vert shader code equals ReadFile. There we go. And we're just going to pass in the name of the file. So since we're already in this is going to be run. When we actually run the program, it's running through tester game, so it's starting in tester game's directory. So if we're doing that, we go from tester game into shaders, and then we grab the SPV file that we need. So since we're starting in tester game, we just say shaders. Is that capital or lowercase? Yeah, it's capital. I don't believe it's case sensitive, but it doesn't hurt to be exact. So shaders, and then vert.spv. So that'll be the file for that, and we're going to make another one. Probably should retype this, but I'm going to be lazy and copy and paste it. It's going to be frag shader code, and we're going to read frag.spv, just like that. So that will read in all of the shader code that we're going to be using. So now we technically have our shaders, but we can't use them yet. This is just binary characters. The shaders need to be wrapped in a VK shader module to be used. So we're going to need to create another function to handle that. So let's hop back over to our .h file. And under create graphics pipeline, we're going to do a little bit too far. Nope, that was good. Void, and it's going to be create shader module. There we go. Okay, and it's going to have some arguments. We're going to pass in const std vector character reference code. So that's passing in the code that we've already read in. And we're also going to pass in a vdeleter vk shader module reference shader module. There we go. So that's actually going to be what is output. It's going to write to that and alter it in the process. So we're going to copy that, hop over into the CPP, and just drop it right here. And let's not forget to give it the scope. There we go. Okay, so once again, we're going to do things a little bit in reverse because we're doing another create function. So to create the shader module, we're going to go ahead and call if vk create success. I'm sorry, not create success. My brain shut off for a second there. Create shader module. And we pass in the logical device, a reference to the CreateInfo, which we're going to do in a second. So it's going to yell at us for that. Null pointer again, and then shader module dot replace. So it's going to take the ones passed in and alter it. And as always, we're going to check if it does not equal vk success. Because if it does, we know everything worked out. If it doesn't, we need to throw an error. So we're going to say throw std runtime error. Okay. And say failed to create shader module. And if it's successful, we'd like to know. So once again, doing else. And we're going to just say cout shader module created successfully. There we go. Let's give it an exclamation mark. Be real happy about it. Okay, so that will let us know whether or not the shader module is created. And now, since that CreateInfo is not happy with us, we need to create a CreateInfo for it. Alright, so in this case, the CreateInfo is a VK shader module CreateInfo. There it is. Just call it CreateInfo. There we go. So now at least the reference isn't angry anymore. And we're going to set each one of these bits of data. So the S type is going to equal VK structure type shader. There it is, shader module CreateInfo. Once again, a very, very wordy struct there. Alright, now we're going to need a reference to the bytecode that we passed in. So we're going to say CreateInfo dot code size equals code dot size. So it's going to take the code that we passed in, check the size of it, and that's going to be the size that we passed to the CreateInfo. Alright, now this next part's going to get a little bit tricky. So what we need to do is we need to set a pointer to the bytecode, but the reason this gets a little weird is the pointer uses a uint32t format, and not a character format. So we're going to need to realign the data so it matches properly. So we're going to make an std vector, and this is going to be uint32t. Oh yeah, I was doing that right. uint32t. And we're going to call this code aligned. And what we're going to do is we're going to restructure its size so that it's the same size as the bytecode that was passed in when it's divided up to the size of uint32. So we just say code.size over size of uint32t plus 1. Here we go. So that's going to go ahead and make this vector the same size as our code if it were using uint32. Alright, then we're going to copy all of the data from the vector that was passed in to this new vector. So we're just going to do a mem copy, and we're going to say code aligned dot data. There we go. And then code dot data and over code dot size. All right. And then we assign the data from the temporary vector to the pointer. So CreateInfo pcode equals code aligned dot data. There we go. So that handles everything we need for the create function. So the shader modules that we're going to be making with these, they are, VK objects, but they're not something we're going to need to keep referencing later on. So we don't actually need to declare them in the .h file the way that we did before with all the other ones. This we're actually just going to create temporarily in the createGraphics pipeline function, and they can be thrown out when we're done. It's not really going to hurt anything. So we're just going to declare them right here. We're going to go ahead and say vDeleter. I'm going to enclose a VK shader module. We'll call this the Vert Shader module. And we're going to pass in logical device and a VK destroy shader module. There it is. Okay. And I'm just going to copy and paste that again. Once again, if you're doing this, be very careful that you change everything you need to. So, frag shader module, logical device, VK, yep, that's all good. So now we're going to call that create shader module function, and we're going to pass in these temporary VK shader module objects. So, create shader module, there we go. And we'll pass in the Vert Shader code and the Vert Shader module. Do it again. Create shader module, frag shader code, frag shader module. Okay, so that'll create both of the shader module objects that we need. So now that we have the objects, we need to make sure that Vulkan uses these shaders as they're intended. So they have to be assigned in a CreateInfo struct that'll be passed into the create function for the pipeline itself later on. So first we're going to make one for the Vertex shader. Vulkan has enumeration for each stage, so we're going to set this one in just a second. So we do VK pipeline shader stage CreateInfo. There we go. Everything's very wordy in this. Vert shader stage info. Okay. And vert shader stage info dot s type I spelled it wrong. That's why I wasn't recognizing it. There we go. S-type equals, and here comes another wordy description, VK structure type pipe pipeline shader stage. There it is. CreateInfo. And vert shader stage info dot stage, and if you remember I said that there's an enumeration for this. We're going to go ahead and say VK shader stage vertex bit. So now this knows that it is our vertex shader. Now we need to pass in the actual shader module that it's going to be using. So we're going to say vert shader stage info dot module equals the vert shader module that we just declared. And we also need to tell it which function to call in the shader. Now, since we created that ourselves, you know that it has a main function, and that's really the only thing we can call in it. So we're going to say pname equals main. Alright, now we need one for the fragment shader as well. So once again, it's going to be another VK. You know what, I'm just going to copy this. Once again, if you're going to copy, make sure you don't copy things wrong. So frag shader stage info, frag shader stage info dot s type equals, and I'm just going to copy this one too because that's super long. And that one is the same. The s type is the same, the stage is different. That's what declares, frag shader stage info. That's what declares what type of stage this is, and obviously it's a different one. So we're going to say VK shader stage, here we go, fragment bit. Okay. Then frag shader stage info dot module. Once again, it's going to be frag shader module and frag shader stage info dot pname equals main again. There we go. And finally, we're going to take the two shader stage infos that we created, and we're going to add those to an array. It's an array of shader stages. We're going to use them later on when we're creating the actual pipeline. So VK pipeline shader stage CreateInfo shader stages array equals, and we're just going to assign those right in. So just vert shader stage info frag shader stage info. So there you have it. So that's everything we have for this episode. We've now set up all of the vertex shader, the fragment shader. We've compiled them, and they should read right into here. So let's go ahead and run this before we end, just make sure everything works properly, because if it doesn't, I'd like to figure out where I went wrong. Okay, and we should see output telling us that the shaders were created successfully. Let this compile. Hopefully it won't take too long. There we go. And haha, we're good. So notice right here, image views were created successfully, and then those are the shader modules. One is for the vertex, one is for the fragment, so everything worked out nicely. We're not going to be able to test it quite yet until we start getting some of the other components of our graphics pipeline setup. So that's all for this episode. Thanks for watching, guys. In the next episode, we just finished our programmable stages, so we're going to be working on the fixed function stages. It's still going to be a few more videos before we get anything visibly rendered on the screen, but we're getting pretty close, so thanks for sticking with this. I know it hasn't been super exciting yet, but it's going to get there. Thanks again for watching, and as always, feel free to post any questions in the comments section, and I will do my best to help out.